So for the online students, I just told the people in class the computer's not connecting with my tablet today. So we're going to be working from this whiteboard on topic 5.2 on page 253. If you want a copy of what I have on my tablet, just send me an email message and say, please send me a copy of 5.2, and I will click on the little button here that says share and type in your email address and it'll send it to you. I think it'll send you the whole file that's got all the lessons in it, and you just click on 5.2 to look at that one. But on page 253 in problems 1 through 4, it tells you to graph each indicated set of numbers. So for problem 2, they want me to graph the integers between -5 and 6. Here's 6, 5, 4, 3, 2, 1, 0, -1, -2, -3. How far am I going? -5, -4, -5, -6, and we'll just put one more up here, -7, and it says graph between -5 and 6 inclusive. So I want to include -5, and I want to go up to 6, and I want to include all the integers in between. So I just put a little purple circle on each one of those. Okay? And that's what it means to graph it. Now for problem number 4, this is problem number 2. For problem number 4, it says, now watch how this reads. Graph the natural numbers between -2 and 4. So I make another number line, put a 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, and they want me to graph all the what kind of numbers? Natural numbers between -2 and 4, between -2 and 4 inclusive. But they want natural numbers. You know what natural numbers are? It's the way things naturally occur. How do people naturally occur in this room? One at a time. 1, 2, 3, 4. So the natural numbers are the numbers that we count with. 1, 2, 3, 4, 5. So I put a little purple dot on 1, 2, 3, and including 4. If it said between, I would stop at 3. If it says inclusive, I would include 4. Okay? So what about problems 5 through 8? Find the additive inverse of each number. So here's what that means. Let's see, what's the first number? 47? Boy, this seems archaic, doesn't it? Writing on this whiteboard after we've been working with that tablet. So I have 47, and it says to do what with 47? Find the additive inverse. Well, 47 plus its additive inverse equals the identity element for addition. Does anyone know what the identity element is for addition? What number can you add to any number and it doesn't change that number's identity? what number could I add to 6 and it would still be 6? 0. So 0 is the identity element for addition. So what number can I add to 47 to get 0 for an answer? Negative 47. So the additive inverse of 47 is negative 47. You got that? So number 8, what's the additive inverse of negative 1,492? $1,492. Okay? Numbers 9 through 16 illustrate each indicated operation on a number line. So, number 10. Number 10 says, what did it say again? Negative 3 minus 2. And they want me to put that on a number line. So I make a number line, I draw a 0, and first I make a move of negative 3. So that would be there. You follow that? I just went from 0, 3 to the left. Then they want me to make a move. Yeah, we'll just use black. They want me to make a move of negative 2. So that would be 2 more this direction. And where do I end up? At negative 5. That's all they want you to do, is just draw a picture of doing those problems on a number line. Like number 16. Five plus negative 2 1, 2, 3, 4, 5 would be a jump of 5. See that? Because it's a positive number. And then negative 2 would be 2 back, and that would leave me at 3. See what's going on? Okay? So that takes care of 9 through 16. So let's talk about 17 through 28. Write each problem as an equivalent addition problem. And that's from page 248. If you want to look at page 248 while I'm doing this, it might help you make sense out of this process. And they even took my music stand. I had a note on that music stand that said, please do not remove this from this room. Dr. Bonine needs it for math class. You know, when you get old, you get no respect. That's all it is. Okay, so let's just look at this stuff. 8 minus 3. Number 18. 8 minus 3. What's number 20? Negative 3 minus 4. What's number 24? 6 minus negative 3. And what's number 26? Negative 5 minus negative 6. Okay? You got those problems there? Now, what am I supposed to do? What did they ask me to do? Rewrite it as an equivalent addition problem. That's the subtraction problem. To subtract is the same as adding the opposite. To subtract is the same, I put down -3, as adding the opposite. To subtract is the same as adding the opposite. To subtract is the same as adding the opposite. Does everybody see what's going on? That's from page 248, where it explains that. So you go, why are they making me do this? Because this is an area where people make a lot of mistakes. So what they're saying is, when you see a subtraction problem, then the safest thing to do when you're working with integers is to translate it to an equivalent addition problem. So 8 minus 3 is the same as 8 plus -3. You go, well, that's so cumbersome because it's obvious that 8 minus 3 is 5, right? And that's the next thing it says. And then after you've done the translation, then it says find the answer. So there's the answer. So you say, well, 8 minus 3 is just 5. Why am I doing this? Because when you come over here, -3 minus 4, let's see now, what is that? -3 plus -4, that's -7. Okay? 6 minus -3 is what? 9. That doesn't look right, does it? And that's why they're telling you to translate like this. And -5 minus -6 is -5 plus 6, which is 1. So that's, I mean, basically for some of them, you could do it in your head and get away with it. But for the 2 at the end, if you did those in your head, you'd probably make a mistake. So the book is just saying, get in the habit of practicing translating subtraction problems to addition problems, to an equivalent addition problem, which is adding the opposite. And then that'll keep you from making a mistake when you're subtracting integers. Okay? Any questions on that part? So now we're down here to problems 29 through 34. And what are we doing here? We're finding the product. What operation is the product? What are the 4 operations you're used to doing in math? Add, subtract, multiply, divide. So which one of those would be product? Multiply. So if you don't know that, make a note. When it says product, that means multiply. So number 30, what's -3 times -4? Well, you know 3 times 4 is 12, right? So the question is, for 30A, is -3 times -4 positive 12 or negative 12? What do you think? Were you taught some rules earlier in life about this stuff?
It's negative because there's only one negative in the equation.
If there's only one negative in the multiplication, then the answer is what?
Negative.
Negative. If there are 2 negatives,
It's positive.
is that okay with everybody? You don't have a problem with that? It doesn't bother you?
It's a really different question.
Would you like to know why that's true? Just for fun? Let's just put a number line up here and have some fun with this stuff. Okay, it's pretty obvious, isn't it? That three times 4. That would be 3 moves of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 4. 1, 2, 3. Whoops. 4. 1, 2, 3, 4. 3 times 4 is 12. Agreed? So what's negative 3 times 4? That would be negative 3 moves of 4. Everybody follow that? That would be negative 12. That makes sense, doesn't it? So what about negative 3 times negative 4? That would be the opposite of 3 times 4. Or that would be the opposite of 3 times negative 4. What's the opposite? 3 times negative 4, or negative 3 times 4, is here. What's the opposite of that? Over here. Do you see what's going on? That's the why of that rule. I always like to have reasons for the rules I have in life. It just helps me swallow the rule a little bit. So for some problem like problem 34, when it says find the product, negative 2 times negative 3 times negative 1. Negative 2 times negative 3 times negative 1. Negative 2 times negative 3 would be what?
6.
Positive 6. And positive 6 times negative 1 would be negative 6. So you just, when you're showing your work on these problems, that's the way to show your work, is just take 2 at a time, because that's the way you multiply them. 2 at a time and write out the answer, and then take those 2 and write out the answer. And that'll show your work. Number 36, if n is a positive odd number, what are positive odd numbers? What's an odd number that's positive? 7. Any others? 5. Let's go that direction. Then what else?
3.
3 and
1.
1. Is that it? And then we go the other direction. 9, 11, ... So now have we made a list of our positive odd numbers? Then what kind of number is n plus 1 to the 5th power? Well, let's just put 1 in here. What's 1 plus 1?
2.
2. What's 2 to the 5th power?
32.
What?
32.
32. What's 3 plus 1?
4.
What's 4 to the 5th power? 4 times 4 is 16. Times 4 is 64, right? Times 4 is 200, what is it?
256.
256. Well, do you want to do, let's do 9. What's 9 plus 1? What's 10 to the 5th? 10 times 10. Did we do this to the 5th?
That's to the 4th.
That's to the 4th. What is it to the 5th? What? You're not going to tell me? Well, then I'll look down here and figure it out. Four to the 5th, 1,024. Nine plus 1, 10 to the 5th would be 1 with what? 1, 2, 3, 4, 5 zeros, 100,000. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. So do you see a pattern with the answers? If n is a positive odd integer, that's what we have listed up at the top, what kind of number is n plus 1 to the 5th? What kind of numbers are those answers?
Even.
What?
They're even.
Even. They're even positive numbers. See, you read that question, you go, I don't know. Then you say, well, let's just walk through the process and we'll figure it out. Page 254. On 254, it says in problems 37 to 46, refer to the chart in example 4. That's the chart on page 251. So you'll have to turn back to page 251 in your book and look at that chart to answer these questions. So let's look at number 38. What integer corresponds to the math score of test takers whose parents earned an associate's degree? You see where it says associate's degree on that chart on page 251? What am I looking for? Math score. Which color is math?
Blue.
Blue. See the little box in the corner? Verbal is red, math is blue. What's the integer?
Negative 23.
So I put negative 23 up here. There. Did I answer question 38? Am I done with it?
No. Yes.
What's the next question on 38? On 38, what's the last question?
What was their score?
What was their score? Okay, the integer is negative 23. What was their score? It's like, I don't know. See, this is so sad. It tells you to look at the picture on page 251, and then it doesn't tell you what the scores are. You have to go down and read the paragraph under the picture, and I just got so frustrated with that, I put down the math average. What was the math average for those little boxes? Here's math, and here's verbal. And what's the score for math? Do you see it there from the paragraph below?
514.
Yeah, 514. So 514 is the average math score. What's the average verbal score?
506.
506. So I just wrote those right next to my chart. I don't know why the people who put that chart there didn't put this information down there, that this is the average verbal score, and this is the average math score. And this person, whose parents earned an associate degree, scored, what was their score? If they were minus 23. Have you figured out what minus 23 means? That they scored 23 points below the average. And this is math, right? So we go 514 minus 23. And their score was 491. Okay? Which one is that? Number 38? Yep, that's what it says on my tablet, 491. You follow what's going on? Problem number 40. What integer corresponds to the math score for test takers whose parents earned a bachelor's degree? So now I look at this chart on page 251. I go down to bachelor's degree, and I already forgot what I'm looking for. Am I looking for the red or the blue number? You're not going to help me? They said math, right? So I'm looking for the blue number, and what's the blue number? Is it plus 19? So that's the first answer to question 40. Then what's the second question? What was their score? And I look back at my math average, and I go 514, and I add 19 points. And their score was 533. Everybody follow that? See why it bothers me that the people who drew that picture didn't put, all they would have to do is outside the box, just put SAT verbal average 506, SAT math average 514. So I just wrote those numbers in my book right by those two little boxes because they're going to keep asking me about it. So I need to have the number by the picture so I can answer the questions. Okay, what's 42 say? Find the difference between the integers corresponding to the verbal and math scores for a test taker whose parents did not earn a high school diploma. No high school diploma. Negative 95 and negative 76. Oh, those are the numbers they already gave us. So what's the difference between negative 95 and negative 76?
Negative 20.
Negative 20? If I have negative 95 and I subtract negative 76,
Oh, 76, not 75.
would be negative 95 plus 76, and that would equal
Negative 19.
negative 19. Okay? All right. Is that all they want to know? Because see, now they've asked two questions in each question, so now I'm looking to see, are they asking more than one question? Nope, that's all they wanted. Number 44. Find the difference between the integers corresponding to the verbal and the math scores for test takers whose parents earned an associate's degree. So I look at associate's degree, and I look at, what do they want the difference between? verbal and math. So I want verbal minus math for associate's degree. So what's verbal? You don't want to tell me? Is it negative 14? Minus math, which is what?
Negative 23.
Negative 22. So that's negative 14 plus 22. So that would be what? 8? Is that right?
It's negative 23.
Oh, it's negative 23? Oh, man. I got to copy stuff down right if I want the right answer, don't I? So then what is it? Nine? You go, I don't know, I'm having trouble seeing that. Well, then just draw yourself a little number line. Here's 0. Go 14 to the left. And then go 23 to the right. And where do you end up? Back to 0. And then from 14 from that would be 9. Anytime you look at an answer and you say, that doesn't feel right, just draw a little number line and draw a picture of it, and it'll help settle it in your mind. All right, that's enough of that. Order of operations. Do all of you know the order of operations for mathematics? It's on page 252. What do you do first? Parentheses. You always work the parentheses first. What do you do next? Exponents. Are any of you saying that little riddle? Please, excuse. That is so sad. But it works, doesn't it? What's next? That would be multiplication. D, division, Aunt Sally, addition and subtraction. So you do multiplication and division before you do addition and subtraction. But be careful here, because page 252, that little riddle kind of leaves one thing out. You do multiplication and division from left to right. Then you do addition and subtraction from left to right. So that's where sometimes it'll catch you, and just write yourself a note. Since you get to bring notes to take the test, you don't have to memorize my dear Aunt Sally riddle. You just say, I'll just write it down. But remember to put down in your instructions, left to right. Always left to right. Multiplication and division, left to right. Addition and subtraction, left to right. So let's try to work through one of these, like 48B or 48A. Doesn't matter. Let's do 48A. What do we do first? Parentheses. What's negative 3 plus 1?
Negative 2.
Negative 2. And then that's multiplication. You go, well, there's no multiplication sign there. No, when they don't put that sign in front of the parentheses, what operation does it mean? It either means add, subtract, multiply, or divide. And you say, well, it means multiply. So write that down. So it's negative 2 times negative 2. And what's the answer to that problem?
Positive 4.
Positive 4. Now, if that were on the test, would the guy who wrote the test, would he put down negative 4 as one of the choices? Yes, he would. You know he's going to try to get you to make a mistake. Number 50. What do you do first? Parentheses. What's 4 minus 8? 4 plus negative 8 would be negative 4. And what do you do with that negative 4? After you've done parentheses, what do you do? Exponents, but there aren't any, so you multiply. So now you have negative 2 times negative 4. That gives you what?
8.
Positive 8. And positive 8 minus 9 would be
-1.
negative 1. Number 52. If you do the parentheses first, what's negative 3 minus 5? Negative 3 plus negative 5 would be
-8.
negative 8. What's 3 plus 5 plus 4 minus 5? What's 3 plus 4?
7.
7. What's 7 minus 5?
2.
2. So I have negative 8 times negative 2, then plus 8 times 2. What's negative 8 times negative 2?
16.
Positive 16. And what's 8 times negative 2? No, what's 8 times 2? 16. What's 16 plus 16?
32.
32. Everybody follow what's going on here? You just work through it a piece at a time. And the way you show your work is you just write down what you're doing underneath here and keep track of it. Number 54. Let's just put that one up here on the board. 8 divided by, where'd it go? 54. 2. Then it says what? Times 4, then minus 8 times 2 divided by 4. Minus 8 times 2 divided by 4. So what do we say about multiplication and division? Left to right. What's 8 divided by 2? 4. What's 4 times 4? 16. Everybody follow that? What's 8 times 2 divided by 4? Left to right. What's 8 times 2? 16. What's 16 divided by 4? 4. What's 16 minus 4? 12. You see what's going on? Now, if you would have done 2 times 4 first, and then have 8 divided by 8, you would have 1 there. You follow what would happen? That's why you don't do multiplication and then division. You do multiplication and division in the order from left to right. So that's why if you weren't given that rule earlier in life, if somewhere in your math world people gave you incomplete information, now is the time to add to that information all the stuff that keeps you from messing up. And you go, yeah, my teacher told me to do multiplication first. That's why I messed up and missed some of those problems on that test. Well, send your teacher an email and say, would you please tell the rest of your students from here on out that you do multiplication and division from left to right, not multiplication and then division. but multiplication and division left to right. But everybody just loves, please excuse my dear Aunt Sally, and they often just get the riddle down and then don't remember the nuances that have to do with being careful about math. Let's do number 56. What's the first thing we do? I think I'll just put that up here because you kind of need to look at it to see the dynamic of what's going on. So 56 says 5 times negative 2. Then what's it say? Times 3 to the second. That's in parentheses, isn't it? That's what they did, so we'll do the same thing. Plus 6 divided by 3. And then what? Times 5 times 3 to the second. So what's the first thing we do? Parentheses. You say, yeah, but there's nothing to do here. It's just negative 2. Okay. Then what's the next thing we do?
Exponents.
Excuse. Please excuse. Exponents. 3 squared is 9. 3 squared is 9. So now what do we do next? Multiplication and division from left to right. So what we have here is 5 times negative 2 times 9 from left to right would be 5 times negative 2 is negative 10 times 9 is what?
Negative 90.
Negative 90. Then over here, 6 divided by 3 times 5 times 9, left to right. 6 divided by 3 is what?
3.
Times 5 times 9, 90. Add those two, and what's the answer? 0. Is that right? Sure enough. That just doesn't seem right to do all that work and get 0 for an answer. Just trust your heart, Tom. Just go ahead and make it 180 or something so it looks good and you feel good about it. And then see what happens when you check it in the back of the book. Even though I do this stuff all the time, my heart still messes with me. My heart is just as deceitful as yours is. So you have to keep checking yourself, saying, got to keep track of this stuff. Okay, number 58. Julius Caesar died in 44 BC. And I hear somebody in their little heart saying, who cares? He died in 44 BC. Well, we're working a problem. Nero set fire to Rome in 64 AD. Set fire to Rome in 64 AD. Find how many years elapsed between Caesar's death. How far is it from here to here? Well, here's 0, right? Is that right? This is 44 before Christ. And this is 64 in the year of our Lord. You go, no, my textbooks always said BCE. I know. Before the Christian era bothers some people, so they decided to do away with the word Christian and changed it to before the common era. So that's when you see that E on there, they've decided to leave the word Christian out of there because people don't like us. Who knows why? We're the nicest people on the face of the earth. What's the problem? So that was before Christ was born. So watch this. So now this is the common era. But the common era is measured from what point in history? the death of Christ. I mean, you understand, or the birth of Christ. So you understand that the common era people don't even realize that they've changed the name, but they're still using the birth of Christ as a measuring point in the history of the human race. And in case you're wondering, before Christ came to this earth, how did people measure things? Well, I mean, talk about egotistical people like Julius Caesar and others. When they came to reign, they changed the calendar to now we measure things during my time as King of Kings in the country. So they measured time based on, in the reign of Julius Caesar, year so-and-so. And somebody said, checking out history, it makes sense to just go take some significant person in history, not some Chinese emperor, not some Russian czar, not some Roman leader. Let's take someone who everyone could look at as a focal point in history. And what did they do? They chose our Savior and Lord Jesus Christ and said, he's the most significant person in the history of the human race. And now people have become so educated that they've decided that's not very appropriate, so they call it the common era. What commoners they are to do that. Anyway, it hasn't changed the way we measure things. The Jewish people still use their Jewish calendar, I think, don't they? Do any of you know what year it is in the Jewish calendar?
5,000 something, like 500.
Because they measure time from when?
Creation.
From when they started sunrise and sunset in the Garden of Eden. They concluded that's when it started, so they measure time from there. I think the Chinese aren't using, I mean, they do this for business because everybody does this to do business with us, but I think the Chinese still use some of their own. I mean, you can look to see what year is it in China, in Russia, in whatever, and you can find out who's using this system. But what is it? From 44 to 0 to 64 would be what? 108 years? Is that any problem? Now it says use signed numbers to work it. Well, what would that be? That would be what? 64 minus negative 44? That would be 64 plus 44. Do you see that? But just looking at the picture, from 0, 44 back, from 0, 64 up, that's 108 years difference between when that happened. Okay, according to my book, you're supposed to stop when you get to number 59. No, you don't work number 59. Stop when you get to 57. So stop when you get to 57. Oh, probably if we'd have been using our tablet, we would have been moving faster and we could have covered part of 5.3. But since the machine's not working right, you get a break. We stop with 5.2 today and we'll double up down the road somewhere. And if you want, yeah, I'm looking at this with black. It does look much better. Maybe I should take all these blue ones out of here and replace them with black. You can see it much better with black on the screen. If you're having trouble seeing this stuff and you want to see the whole thing from my tablet, just send me an email and I'll send it to you.